Hello everyone, good morning. I welcome you all for the Things Virtual Conference 2020. Myself Rathinasamy KS from Enthu Technology Solutions India Private Limited. Today my session is about my LoRaWAN setup, precision agriculture with LoRaWAN. Along with me, Mr. Mallesh, the CEO of CultYvate, will also present this session. Thank you everyone to come and attend this session. Let's understand about CultYvate and Enthu Tech. CultYvate is a precision agriculture company who is having more than a decade years of experience in agriculture. They are providing the IoT solutions along with artificial intelligence and machine learning to increase the crop productivity with a very less water usage. So they are the company who is providing the IoT solutions for agriculture in India as well for the foreign markets. Now it's about Enthutech. Enthutech is a company who is developing the end node for CultYvate, and Enthutech is also developing end nodes for some of the other verticals like industrial automation and as well the smart water meters. And Enthutech is a system integrator for LoRaWAN in India. Enthutech is also a technical support partner for the Things network in India. Let's see the topics what we are going to see in this presentation. So first we will talk about the current irrigation approach and the existing associated problem with that, and CultYvate solution. So these two topics will be presented by Mr. Mallesh. And after that I'll take over the session and I'll present you about the one of our deployed systems setup, the complete end-to-end setup. I'll explain you about the end node, and I'll explain you about the gateway and the LoRaWAN network server, that is the Things Industries. And I will explain you about the application platform that currently we are using. Ubidats as our application platform, and overall how the system is being deployed and how that particular system is working to derive the precision agriculture solutions, and what are the benefits we are deriving from this precision agriculture systems. Then we will move on to the question and answer session. Thank you, and I'll hand over the session to Mr. Mallesh now.
Hi, good morning. My name is Mallesh. I am the CEO and founder of a company called CultYvate. We are an India-based company and we work with farmers in providing smart irrigation. We are also happy to say that we are one of the first companies in India who started working with Enthu Technologies to provide smart irrigation using LoRa-based technologies. It's a well-known fact across the globe that on an average 40 to 50% of the productivity is lost due to improper watering and incorrect fertigation practices. Most smart irrigation systems what is available in the market, they are either timer based or volume based systems. That means they don't take into consideration any last minute activities such as the temperature or the wind speed or the soil textural classes or the crop age and all these things. When a farmer decides to provide watering based on any of these existingly available systems in the market, they either accept the duration of watering, which could be given in minutes or hours, or the total volume of watering. The key differentiation between these systems and our systems is that our system has got a soil moisture sensor. There are a lot of researches that has been conducted by various research agencies and companies to understand what exactly is the real impact of precision irrigation and precision fertigation on the crops. In the graph that you are seeing, we have taken into consideration three different crops: banana, pomegranate and grapes across 4 different states of India. There is a huge difference between the yield across states and across crops. I am moving on to the slide with the heading precision irrigation. In this there are 3 parts in this presentation, in this particular slide, which talks about what are the key differences between the flood irrigation, the drip irrigation and the precision irrigation. The point is to highlight how exactly the IoT enabled precision irrigation can make a whole lot of difference to the crops. So it's very important to understand what happens to the crop when the irrigation is not regular or when incorrect irrigation is practiced. Typically during flood irrigation, since farmers don't have much of control on the availability of water, or they provide the water only when it is available, they do the irrigation on an average once in every 8 days or 10 days or 12 days. And once they do that, they run the water along the canal that is in the ground, and water percolates deep into the ground. Now, when it percolates deep into the ground, it actually creates the waterlogging. That means it's too much of water, where the water stress is going to be too high because there is too much of water. On the other hand, when the water completely evaporates, the crop will once again go through the stress which is on the other end of the spectrum, where there is too much of dryness. So in both places there is too much of stress on the crop, resulting in lower productivity. Now if you move on to the drip irrigation, this is definitely better than the flood irrigation. But here, since farmer is not understanding the precise requirements of a crop, farmer is giving watering based on his understanding, but of course not necessarily on 10 to 12 days of gap, but it's based on 3 to 4 days or 4 to 5 days of gap. In this slide, I will explain you how exactly we have gone about deploying our solution. To begin with, when you start talking with the farmers, we understand the crop type, we understand the soil textural class, which is very important to understand what is the water holding capacity. We understand the sowing date of the crop. We understand the GPS location so that we can start monitoring and measuring what exactly is happening with reference to other parameters that our sensors are not able to give. The irrigation is going to be very crop specific. That means when we are providing irrigation, even if the crop is same, but if the soils are different or if the agroclimatic zones are different, invariably the irrigation is going to be different. And if you take the same crop but sown in different time frames, which is spread across 15 days apart, then the irrigation is going to be different. Having a sensor driven IoT system will enable us to understand all these things, take corrective action or provide precise watering based on the last minute data that we collect from these things. And how did we go about deploying this LoRa solution? This is what I am going to be explaining in the next slide. Once we collect the basic data, the rest of the activities in terms of the precise watering should happen based on the age of the crop, the temperature of the particular day, right? And what was the wind speed, what was the evapotranspiration. There are various factors that should be taken into consideration to ensure that the crops are being given precise amount of watering, no more, no less. And the other thing that we need to consider is the irrigation is going to be very, very crop specific.
Thank you, Mallesh, for your detailed explanation about the CultYvate solutions and how the CultYvate IoT systems are helping farmer to increase the productivity and also reduce the water usage. Okay, so let's see the how actually the LoRaWAN setup is being deployed in our precision agriculture solutions. What actually the CultYvate is offering. In our LoRaWAN setup, there are two types of end devices. One is called field controller and other one is the pump controller. I'll talk in detail about these two nodes in the upcoming slides. And here we are using the LoRaWAN outdoor gateway from Atsalink. Let's see what the field controller is capable of. So the field controller is connected with the three important components. One is the soil moisture and other one is the solenoid valve and other one is the flow sensor. So our system is in general, actually it is measuring the soil moisture, and based on the soil moisture data, the pump will be turned on via the pump controller LoRaWAN end node from the application platform. So once pump is turned on, then also the solenoid valve will be turned on for the particular plots, and the solenoid valve is turned on, then the flow sensor will start measure how much water is actually flowing with that particular flowing to the particular plot. So once this water is reached the threshold capacity, then based on the soil moisture data, our application server will send a downlink to turn off the pump as well to turn off the solenoid valve. So basically we are measuring the soil moisture, and based on the soil moisture data we are watering to the crops only for the necessary amount of water, then we are stopping the water. So this is the overall flow. And also this LoRaWAN end node is working with a 3.6 volt battery and also equipped with the solar panel for the continuous operation. And also this is an IP66 waterproof enclosure where it is actually deployed in a field, and it is consuming very less power, like 0.05 milliamps while sleeping, and operational it is consuming around 135 milliamps. So it is also a low, it's working in a LoRaWAN class A. So and also we are working on LoRaWAN class C models for our next upcoming deployments. As I have mentioned already, The pump controller is another LoRaWAN end node we are using in our deployments. So the main objective of the pump controller is to control the pumps which is available in the field based on the downlink commands from the application platform. So this pump controller is capable of controlling the single phase and as well three phase pumps. For this deployment, we are using the gateway from Arsalink. So the gateway model is UG87. This gateway is an 8-channel gateway with multiple backhaul connectivity options. So it supports for 4G and it supports for the LAN and as well it supports for the power on Ethernet. So this gateway is one of the effective gateway for our most of our deployments. So we are also the technical and commercial partner for Arsalink in India. So being a system integrator, we are recommending CultYvate to use this particular gateway, and we are also seeing the better results with this gateway. For this deployment, we are using Things Industries as our LoRaWAN network server. So currently we are using the TTI version 2, and also we are exploring the options for TTI version 3. So once TTI version 3 is come up in commercial version, then we will migrate all our CultYvate applications to TTI v3. So currently you could see the screenshot where actually we have registered the devices for this particular deployment, and some of the devices are already sending data. That also I have put it as a screen capture here. So being a TTN user for a long time, and we are seeing that Things Industries is offering the one of the best solution for integrating the LoRaWAN systems in a very quick time, and also it is having some of the interfaces where we could able to integrate our application platform in a quick time. For example, currently we have used Ubidots as our application platform, and we have very direct interfaces for Ubidots, and we could able to just create an API key and integrate the Ubidots and the network server. As I have mentioned already, so our system is working on based on the soil moisture sensor value. So based on soil moisture sensor, the application platform triggers the pump and triggers the solenoid valve. Once water reaches the threshold level, that means the soil moisture is reaching the threshold level, then automatically the application platform sends the downlink to turn off the solenoid valve and as well the pumps. So if you see, this is our IoT dashboard where we are displaying the soil moisture level, and also we are displaying the battery, and we are giving the all useful informations which is very much important for the customer perspective. These are the important benefits of the CultYvate precision agriculture systems. So one is it is reducing the water consumption to up to 20%, and also it is increasing the crop productivity up to 20%. So these values are derived from some of our proven systems and deployed solutions. We have derived this data, and thank you everyone for attending this session, and you do visit CultYvate website or Enthutech website to get clarity on our systems, and also you can ask if you have any questions now. Thank you.